So gravity is not attraction. It is the property of the geometry of the space-time created by the mass of each individual object. So in this concept of general theory of relativity, if two objects are going very heavy, very small, going around each other very fast, what will happen? They will create a ripple in the space-time. And this ripple is called the gravitational wave. 2016, 100 years after general theory of relativity, this gravitational wave was detected by two of the fascinating observatories in US called LIGO, Laser Interferometric Gravitational Observatory. And you'll be very happy to know India is the first international associate of LIGO project. In Maharashtra, they have started building what is known as Indigo, Indian Gravitational Observatory. The cost may turn out to be around 2,000 crores. So, as young students in the subcontinent of India, you should realize that there is a tremendous amount of focus. You know about space science, a lot of things are happening. Same is true for astronomy and astrophysics. Night sky. Night sky. Thousands of years back, our ancestors used to look into the night sky and they used to wonder, what is the meaning behind those lighted dots we call stars? But they couldn't get an answer. In their desperation, what they did, they chose different parts of the sky, identified closely spaced stars, joined those stars through straight lines, and created imaginary figures. In this way, the whole sky was divided into 88 regions, each region being governed by an imaginary figure, which we today call constellations or Taramandal. You will be wondering that these are imaginary. Why should we know about them? And just to give you an idea, for the last 22 years, I'm in Kolkata. Almost every year, I go down to South India in a place where there is Indian Army's Advanced Commando Training School. Every year, I have to teach the fresh batch of Army commandos for 6 nights how to read the night sky. Because if you can read the night sky properly, without a lot of sophisticated instrument, you can get a lot of information around this. Just to give you an idea, suppose a batch of you has gone for a hitchhiking trip, night has happened, moon is not there in the sky, you have lost your way, somebody in the morning told you that if you go in the southern direction, there is a locality. But which is the southern direction? If you happen to see the Saptarshi Mandal, 7 stars called the big beepers in Western parlance, take the last 2 stars, join them in your mind, produce it onto the sky, it will hit up on a single star, and that star is the pole star. The moment you know the pole star, you know which is not south star. So you see how you can utilize the sky for your benefit even today. The sun, moon, and the earth. You'll say, what nonsense. We have all studied it in our kindergarten classes. Why are you talking about it? But amazingly, believe me, when I asked even a lot of teachers, can you tell me what is the average velocity of Earth around the sun? Google. 29.5 kilometers per second. Imagine a car in 1 second moving 30 kilometers. It's not possible. We are forgetting you, me, 780 crore people, millions of life existing on the surface of the Earth. Every second of our existence, we are moving with a velocity of 30 kilometers. But do you think you are sitting tight? I don't think I'm standing straight. Amazing. One more thing I wanted to say, which people are realizing it more and more, that we exist, that I'm standing here now, that you are sitting here now, and we'll be having our lives. We think so many factors are important. We think so many issues are important for us. First of all, we think we are the most important for ourselves. Then either muscle power or intelligence or money, and places like West Bengal, a lot of political patronage, whatever, powerful. But we tend to forget that we are alive on Earth, that life originated on Earth is based on a series of accidental chance happenings. If one of the factors were not there, because it would not have been possible for life to happen, forget about continuing. We are all dependent on chance accidents for our existence. We forget that. When you look into the cosmos, the enormity of the situation hits us. And that tells us we are all just small specks of dust, not that important as we make ourselves believe. Sorry. For example, change of seasons. You all know this. Nowadays, class 3, class 4 geography textbook. It happens because Earth is tilted by 23.5 degrees. So sunlight at one time falls directly onto a patch of land. The average energy per unit area which will be absorbed and radiated will have a value. With the same sunlight falling slantingly on a bigger patch of land, the average energy per unit area which will be absorbed and radiated will have a smaller value. As a result, the temperature will be more in the first case than the second. And that is the reason summer and winter occurs. So it's a fine. So what's the big deal about it? Do you know, if there were no change of seasons, what would have happened on Earth? If there were no change of seasons, there would have been no ocean currents. If there were no ocean currents, there would have been no air currents in our atmosphere. And if there were no air currents in our atmosphere, clouds would not have born somewhere and gathered somewhere else and gave us rain and fresh water. Life would not have been possible because there would have been no water. It would have been a barren desert. So my friend, next day when you say, aha, I'm here, I have arrived, cool. You have to tell yourself, yeah, correct, but there is, because it is tilted by 23.5 degrees. That is it. Right. Solar eclipse, you all know. Sun, moon, earth, sun's rays falling onto the moon, moon shadow falling into a small patch of space, and people staying on that patch of space, sees sun vanish for a couple of moments, minutes or so. Right. And one of the most beautiful picture of the nature. This is a true picture actually. Getting covered. It was during an eclipse. Sun was discovered as a new star. They found out from the surface of the sun, milky white radiation coming out, which cannot be seen on other times. When they asked themselves the question, what is causing this? They were amazed with the answers. They found out from the surface of the sun, every second, or an average, 1.6 million tons or 16 lakh tons of charged particles are coming out. These charged particles, as they move through the magnetic field of the sun, they produce this milky white radiation. The average velocity of these charged particles are 450 kilometers per second. With that speed, 450 kilometers per second, the momentum they have, if they hit any atom or molecule, instantaneously it will break apart. Basically, it means if I stop my lecture, go out and stand on the sun, the charged particle coming from the sun, the moment they hit my body, within fraction of a second, my whole body should disintegrate. Evaporate, poof, but I am alive. How? I'll come. Tides. You'll say, come on, these are, where are the stars? But let me talk about why tides occur. First of all, if I ask you, why does tide occur? Oh, I know the answer, sir. It is moon which is attracting the water on the earth, causing the tide, right? But my friend, you have all studied Newton's laws of gravity, m1 m2 by r square. If you do a simple back of the envelope calculation today, you can show sun is attracting earth 173 times more than the moon does. That is the reason earth is going around the sun. Then why do you say it is moon which is attracting? It's a distance at m1 m2 by r square, distance is constant. See, these are the problems with us. We just go by the book without asking questions. In the morning, I mentioned, right? Professor Debray also mentioned, ask questions. Why? The answer is, tide is not a force. Tide is a resultant of quite a number of force over unit distance, or what is known as force derivative, m1 m2 by r cubed. And that is the reason, since moon is 384,000 kilometers away and sun is 15 crore kilometers away, moon wins. But how many of you know sun also attracts the water on the earth? You know how much? 47% than the moon does. You will not find this discussion anywhere. Amazing. Okay, fine. I'm standing here. The moon has arrived. Because of the moon, water bulges towards the moon. I say high tide, right? This geographical location, after 24 hours, will come back over here. Vinny. By that time, moon may have shifted a little bit. So roughly, after 24 hours, I should have another high tide. But how many high tides are there? In a cover Josh. Why? Simple. You would say these are class 1, class 2 questions, but give an answer. Answer is like this. I'm over here on the water here, moon is there. There are two forces acting. One is gravitational force towards the moon. One is the centrifugal force. And if you do the calculation, gravitational force is more, water goes in this direction. But if you go in the opposite direction, 180 degree away, the centrifugal force becomes more because 1 by r square distance has increased, the gravitational force has come. So next time, when you go to the Ganges and see the high tide, or Digha, Puri, wherever you go, you should tell yourself, I'm seeing this high tide. At this very point of time, in the rivers of Mexico, high tides are. Because Mexico is bang opposite to India, West Bengal. That's the reason two high tides are. Moon, beautiful picture taken from near the surface of the moon. What is moon? According to 99% of the scientists, 452 crore years back, or 4.52 billion years back, a huge ball of rock came and slammed onto the earth with a tremendous force. The collision was so tremendous, huge amount of material and surface material was gouged out and was thrown up into space. It couldn't go away forever, but going to a very vast distance for billions of years, it condensed, coalesced, coagulated, and ultimately gave birth to the moon. Moon was born out of Earth, right? 99% of the scientists believe in this, and it is called the collision ejection theory. In Wikipedia, you'll find giant impactor theory of the same. Let us start our journey. I've spent almost 15 minutes, 20 minutes, but now let us begin the journey into space and time. Why space and time? I think you know. 1905, Albert Einstein, special theory of relativity. Result was that light has a velocity, which is constant. The velocity of light is 3 lakh kilometers per second. The distance from sun to earth is 15 crore, 3 lakh kilometers per second. A small division, class 8, 7 textbook tells you the distance from sun to earth is 8.3 light minutes. Distance, light minutes. A light takes 8.3 minutes to come from sun to earth. But physically, if you realize that, it's an amazing thing. If you go out now, for a fraction of a second, look at the sun. You tell yourself, the sun I am seeing now is the image of the sun as it was 8.3 minutes back, and I'm seeing it now. The closest star, Proxima Centauri, 4.2 light years away. Today evening, if the sky is clear, look at the star and tell yourself, the star I'm seeing now, it is the image of the star as it was 4.2 years back, and I'm seeing it now. So next time, your younger brother or sister tells you or your parents, please take me to the science city, spend 50 rupees on a time machine ride. On a clear night, go out into the open. Tilt your head. The deeper you are seeing now, you are seeing your own past. We don't understand. We do an instantaneous time travel the moment we think of the film. Don't time travel. Go and have it. Right. The first of our journey, obviously, solar system. These are all true color pictures of the main avatars: Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Poor Pluto has been kicked out from this group. Sun. Sun is a ball of gas. All done your projects. So tell me, my friend, if you take a football, pump in a lot of colored gas, cut open the football, will the gas inside remain like a ball? It will diffuse out. Then how come sun being a ball of gas is not diffusing onto the sky? How it is holding its shape? What does the scientist say? According to the scientist, 460 crore years back, or 4.6 billion years back, a huge cloud of gas and dust was floating in space. This All right. This cloud, in terms of number of particles, was made up of 91% hydrogen, 8% helium, 1% rest other elements. The average temperature of this gas cloud was minus 240 degrees centigrade. At minus 240 degrees centigrade, out of the 4 fundamental forces of nature, do you know that there are only 4 types of forces in nature? Suppose I slap myself, sound came out. What is this force? Tell me. If you know, there are 4 fundamental forces. Question. This is electromagnetic force. Yes, fine. So where is electricity, where is magnetism? The problem is it's an electromagnetic. Okay. Out of the 4 fundamental forces of nature, only one type of force comes into play, and that is the force of self-gravity. The force of self-gravity will attract the periphery of this gas cloud towards the center. As the gas goes towards the central density builds up. As the density rises, pressure rises. As the pressure rises, temperature. Initially, PV equal to in Earth, Charles law was. And temperature starts rising, and ultimately it reaches a fascinating level of 1.5 crore degrees centigrade. At 1.5 crore degrees centigrade, 4 hydrogen nuclei, protons, this 4 hydrogen nuclei, they come and fuse together and produce a helium nucleus. This thermonuclear fusion reaction, scientists have been able to perform it in our labs, but they cannot control it. That's the reason they use it to explode a hydrogen bomb. But inside the sun, in a very regulated manner, when 4 hydrogen nuclei converts to helium nucleus, huge amount of energy is produced. As the energy tries to come out, it produces a back pressure called radiation pressure. Have you heard about the term radiation pressure? See this light shining. Light is falling on my body. It is actually producing a pressure. Right? If the light was very powerful light, ultraviolet, it will produce more. If it was X-ray, the pressure will be so much, it will pierce. So any radiation falling on anybody produces a pressure. So this energy which is produced, as it tries to come out, it produces a back reaction pressure, radiation pressure. This radiation pressure, when it exactly balances and matches the inward force of gravity, sun being a ball of gas, remains hanging there for millions of years without this. So my friend, today when you go back to your house, evening, or your hostel, wherever you will stay, for 1 second, think about this. That we are all alive. Every second of our existence is dependent 15 crore kilometers away in a ball of gas to opposite forces are continuously cancelling. No Dada, Didi, Mama, Kaka, Jaka is supporting us to be alive. So we think, outwardly, inwardly, sun has 3 different layers. The thermonuclear fusion reaction happening at the core, huge amount of energy freely flowing out to a region called radiative zone, and 650 to 700 kilometers from the surface of the sun, right? There are big columns of gas, pillars of gas. It comes from inside, hits the bottom layer of the gas pillar. Gas, when it is heated, rises up, comes to the surface, deposits the heat as sunlight, becoming cold like a fountain, goes down and continuously raises the heat. This is called the convective zone. Outwardly, there are 3 regions. The sun that you get to see in the early morning or late evening, like an egg yolk, it's called the photosphere. Over the photosphere, in a very thin layer, exquisitely pink colored gas, spikes of gas, the chromosphere. Chroma means color. And for millions or hundreds and thousands of kilometers, a milky white radiation called corona. The word corona is deadly. No, it's a Latin word. It means crown. Coronavirus looks like the crown, so it's called coronavirus. But it's called the corona. This picture on the left-hand side is the actual picture of the surface. Downstairs, there was a video, but somehow, because of some technical snag, I cannot show you the video. It's like a boiling thing. In each column of gas coming up, depositing the heat, becoming cold, continuously coming, going and coming. And this is the chromosphere. This is one of the most beautiful actual picture. Don't think it is Photoshop. Corona, milky white radiation streaming out of the sun. But sun can become very active time to time, right? Black splotches, colored habbas can occur on the surface of the sun. Sometimes one, sometimes 10, 20 in a group. They are called sunspots. What are they? The average surface temperature of sun is 5,600 degrees centigrade. At 5,600 degrees centigrade, gas cannot remain as gas. It becomes what is known as plasma. Plasma has a property. Wherever there is a magnetic field, plasma will try to get deflected. On the surface of the sun, small pockets of magnetism do form randomly. If a column of plasma trying to bring the heat from inside of the sun, if it realizes that there is a magnetic field, it will not come out straight. It will take the heat away from different directions. No heat comes out from this region. It will typically do that. So sunspots are signatures of magnetic activity on the surface of the sun. I want to show you a real picture, right? True picture of the sun. And my friend, do you know what cost this picture was photograph was taken? If you don't believe me, just 1 second, go to Google. $1.2 billion for one photograph. You will say, what nonsense? 2012, $1.2 billion by Solar Dynamical Observatory, a satellite. The reason is, sun is not a very smooth object, right? Every second, tremendous amount of explosions are occurring. Thousands of tons of gas are getting thrown up from the surface, reaching a height of 25,000 kilometers, making beautiful arch and loops, falling back onto the surface. Sometimes they get thrown out with such a force, they get detached from the surface of the sun and flow past the whole solar system like a solar wind or solar storm. True picture taken in 2015. Do you know what is the size of this cavity? 3 Earth will go side by side inside this cavity. This is sunlight. Right? It can occur, see for yourself. Solar flares. And considering the size of Earth will be just like one dot. That we are alive is accident. Believe. I'm not talking magic. These charged particles, as they come, they hit. As I told you, you, me, this building, anything, fraction within instantaneously evaporation. While we are alive, again, by an accident. By accident, Earth behaves like a bar magnet. Around the Earth, like a peels of an orange, there is an invisible magnetic shield. These charged particles, they come and slam onto the magnetic shield, cannot enter, flow past the Earth, and we think we are the king and queen of Earth. Very important thing. But in the north and south magnetic polar region, there is a gap. These charged particles, they do enter the Earth's atmosphere before hitting the ground, interact with the air molecules, and make them glow. And what we get to see? Aurora borealis, north, Aurora australis, south. Believe me, my friend. Nowadays, Facebook, YouTube, you get so many movies. But I will urge you, when you grow up, please experience it. Mind-boggling. When I have seen it twice, it's just no words comes out of you. Fascinating. Right? It's a fascinating. Solar system. How did it happen? Ball of gas and dust, condensing, temperature, but it has a small speed. So what happened? A spherical object, if it is spinning and becoming smaller, you expect a smaller spherical object. Because of conservation of angular momentum, you will expect a disk. So the whole thing circuit on the disk. And at the center, when the temperature rose to 1.5 crore, sun was born. In the outer periphery, where the temperature was less, gas and dust condensed, coagulated, coalesced, and has given birth to hot planets. So now you understand. In the morning, Professor Debray was saying something. What is so fascinating nowadays in the sky? And he said that planets lined up. Why should planets line up? Because we are all part of the disk. So sitting on Earth, if we look in particular direction, if it happens, all the planets will be in a sync. Understand? Okay. So initially, as the sun was getting born, tremendous amount of collision, coagulation of objects, materials, very hot spherical objects were formed. For millions of years, they dissipated away the heat, and this is the first pole. Mercury, Venus, Earth, Mars became solid rock, whereas Jupiter, Saturn, Uranus, and Neptune are mostly made up of gas. You all know that, right? You all know that. But haven't you seen the image of God Jupiter and God Saturn? How do they form the image? It is made up of gas. But that tells you our practices, prejudices. There's a lot of difference from the other. I'm not blaming anyone. But when you go to a street corner, Saturn God, every Saturday, pujas, aarti is happening. It's a ball of gas. That's the reality. You may find it revolting. Oh, no. What are you talking about? Worship, religion. But the reality is a ball of gas. That is what we find. It's a collage of all two color pictures of the planets. Mercury, Venus, you don't get to see the surface of Venus, covered by a thick cloud. The cloud is made up of 95% concentrated sulfuric acid. So when it rains on Venus, it is droplets of sulfuric acid which falls from the sky. Mother Earth, let us not talk about it tonight. We all know pretty well about Mother Earth compared to other planets. Red planet Mars, why red? Covered, it's rusting on the surface, covered by ferrous and ferric oxide. But this 2002 photograph taken by Hubble Space Telescope has interested the scientists because in the north and southern polar region, they have found these white sediments. According to them, this white sediment is a mixture of water ice, dry ice, that is carbon dioxide ice, and methane ice. So according to them, even if a part of it is water ice, maybe liquid water is to flow on the surface of Mars billions of years back. And on Earth, liquid water means life. So was there life on Mars? Is there still life on Mars? Big question. Jupiter, 319 times heavier than Earth, takes 12.84 years to go around the sun. But takes only 9.5 to 10 hours to go around the sun. The tremendous spin has dragged the clouds and created this elastic belt-like structure. Saturn, the most beautiful planet of the solar system. Fantastic ring system. Takes 29.4 years. Uranus with a ring. Neptune blue in color, covered by methane-bearing clouds. And our Nanne Munne Pluto, till some years back, it was also a planet with three of its major moons, Charon, Nix, and Hydra. Mars. I think from the day you were born almost, you are all 14, 15, 16. Mars this, Mars that. Every 2 to 3 months, television, newspaper, everything, Mars. Why? What is the big deal about it? Because we have found these sort of features. As if liquid water has cut through the mountainous region. Liquid water means life. Do you know why scientists are so worried also? Is there any life? Every year, on an average, few hundred kilograms of rock come scattered from Mars and land on Earth every year. If the Martian soil or subsoil has some bacteria, virus, parasite now, sitting on a rock, if it lands onto the Earth, 6 months to 3 years, COVID-19. The scientists are scared that whether there is any life form on Mars, they have to know. For the betterment of the human civilization, for your and mine existence. Don't think scientists are a very happy lot, spend a lot of money, goes to foreign countries for attending conferences, have good food in these sort of meetings, and they're having fantastic life. No, please don't. Phoenix landed in 2008. When they scratched a little bit, they found this white sediment. See in the insect, 3 whitish pebbles after 4 days, not to be seen. Is the first proof human civilization have found proof of water ice, not liquid water, outside the boundary of Mars. Next picture is so critical, it has not been published by NASA Open. They want to be 300% sure to make it published official. And I am a NASA educator, so I get hold of these things the day it happens, the day the images are produced. This is the side wall of a trough crater on Mars. This is winter time. Next is summer. And you see these black streaks? Liquid water was found floating on Mars. But NASA want to be 300% sure. That's why they have not published it that way. So definitely there was water and maybe permafrost below the surface. There may be still water. And perseverance, hey, this is not sorry, this is curiosity. Sorry, my friend. Curiosity found out areas, pebbles, which can only occur if there is a flowing water. Totally dried up river beds, the type you get to see in the summer vacation when you go to Chotanagpur Plateau area. Totally dried up river beds. Same. And in between comes 2012, 15th of August. The then Prime Minister declared in the Lok Sabha, India is ready for a mission to Mars. Believe me, my friend, I'm not exaggerating. Almost every country started laughing. India, Mars mission, technologically it is not at all capable. India is capable to do that. Xinhua News Agency, the biggest press agency of our very close friend China, 16th August came out with the news item, Indian scientists are going to prove themselves as clowns and jokers in front of the community. Think about the insult. But you all know the story, right? 5th of November 2013, sitting atop a nose cone of a PSLV X-25 rocket, our Mangalyaan, its officially name is Mars Orbiter Mission, but Mangalyaan was put into space. And India became one of the fantastically proud nations when 24 September 2014 at 8:02 a.m., Mangalyaan was successfully entered into the orbit around Mars. I do not know where you were there. 14 means 8 years back. You were quite kids. But believe me, my friend, the pride, the prestige in the world community about this successful mission was tremendous. But I'm sorry to say, in India, there was a celebration, but hardly anything happened. Oh, wow. Something, we are big. And I've heard a lot of people asking me, whatever you say, 484 crore rupees spent on a mission called Mangalyaan by a country like India, which cannot feed 23% population 2 square meals a day. BPL, below poverty line. Was it needed? 2013-14, according to government calculations and audits, the amount of fireworks that was burst during Diwali and Kali Puja was 5,000 crore. 484 crore rupees. People start criticizing. That is one of the speciality of people in this state system. If you do something good, unless and until they find a hole in it, they will not see it. They always say, oh, brilliant, excellent, but they will add a but. This is one of the problems with our society here, locally, not in general. India was bursting with joy, but here, according to the NASA director, I'm an associate, so I've heard through my own ears, NASA Christmas lecture directors, it's called. Mangalyaan has produced one of the finest camera ever built in the world. Highest resolution image of Mars, taken from a distance of 80,000 kilometers. Think the resolution, 80,000 kilometers. From two-dimensional photographs taken by Mangaljaan, three-dimensional topography is being created by NASA. Think about it. We always try to undermine made in USA and made in Europe. At the most, made in China, better. India has arrived. That should be the message of Azadi Ka Amrit Mahotsav. India has arrived in the world scenario. Whatever you are reading in the newspaper, I understand, not very positive news. This is happening, that happening, religious, these, that, fundamentalism, everything may be correct. But behind that, in the foundation, India is growing. You should understand. You're all growing up. You're very mature compared to your age, or when we were at your age. You're much, much more mature than that. Don't get swayed by senior people, especially who call themselves politicians. They do it for their own purpose. You have to take the right notion, right direction. That is the whole problem. Don't think the school will take the right direction, my teacher will take the right direction, my pa will take the right direction. It is you who have to take the right direction. Each of us. So that is the most important thing. India, the chances that has happened in India is tremendous. And yesterday I was talking to a group of scientists, all young, 40, 42 years age. Their kids are 10 to 11 years old. I said, what do you want your kid to? No, all should go to joint entrance coaching. I said, why? Everybody wants to be an engineer. No, forget about them. If you get an engineering thing, at least you get a job, 15 to 20,000 initially, and if they're good, they will go. Nobody thinks about basic science. I mean, do you know what is the typical salary of an assistant professor starting in a college today? Any idea? 75,000. A software engineer, after spending 16 lakhs of his parents' money for 4 years, and then again spending 3.5 lakhs for a 1-year course, starts at 18 to 24,000. I'm in the HR of, big companies, Tech Mahindra, Infosys and all that. So I know what is the salary scale at present. Don't think that basic science is not that important. If you fail in your joint ventures, what to do? Get into a basic science course. It's the opposite happening now. But one thing, basic science, fundamentals of science are never taught in a coaching center. That rather your parents should understand. Coaching center teaches you how to solve a problem. Why you are solving the way you are solving? Never. What is the physical principle? Never. That again, you have to look after yourself. To be good doesn't mean that you are born as good. How you culture yourself, you cultivate yourself, you motivate yourself, you prepare yourself, defines how good you are. That is the whole problem. Don't say, I don't have this, that much, I'm not intelligent. All nonsense. Intelligence doesn't come like that. It is your acquired knowledge. How you apply it is a test of it. Everybody in your class reads the same book, attends the same class. Then why one does much better than another one? How they have applied. हमारा फेसबुक भी चाहिए, यूट्यूब भी चाहिए, फ्रेंड का साथ वीकेंड में थोड़ा बाहर भी जाना चाहिए, मॉल में भी जाना चाहिए, मूवी भी देखना चाहिए, म्यूजिक भी करना चाहिए, फास्ट भी होना चाहिए. It never. You focus. If you want to succeed, you have to focus. That is the whole point in our educational system. Last year, 3 exciting missions, one by United Arab Emirates called Amal, then Perseverance and Ingenuity, you have all read about it, and Tianwen 1 with the Zhurong rover, all sort of went near Mars, a lot of data happening. But ISRO is much more happy. In the coming 10 years, see the list of projects. Chandrayaan 3, Mangalyaan 2, Lunar Polar Explorer with Japan, JAXA, Gaganyaan, Aditya L1, Shukrayaan, and Indian Space Station. And tell me, 10, 15 years later, who will be manning the console? Who will be testing the rockets, my friend? Maybe one of you here. That's why Azad come. It's you who have to come. This is happening. But who will continue the legacy? You believe. He will say, not a feel-good factor, sir, you talk about, you feel a lot motivated, but after the lecture, think about it. I'm not telling you lies. I'm not making a propaganda lecture of something. This will not pay me by doing propaganda of astronomy, Indian astronomy. I'm doing it because you have talents. Potential is tremendous, believe me. We don't apply our talents to our field 100%. Comfort zone. I was just discussing about the lunch with Shamiji, who gave you a lecture, that how, especially Bengalis, we have got adapted to the concept of comfort zone. Once I get a comfort zone bus, forget about anything. You are the people who can bring the whole society out of this comfort zone concept and strive, take risk, fight, not in the battle, fight with life. Saturn, beautiful ring system, 3 lakh kilometers wide, only 1 to 100 kilometers in thickness. Just see, in comparison, size of what. And fascinating thing, the ring is made up of ice crystals and pebbles. How come ice crystals and pebbles are keeping their shape and size, do not getting dissipated, going round Saturn? It's a big question. And one of my students did his PhD on this, the stability equilibrium of the ring system. It is called non-linear dynamics. You have heard of fractals, right? These stabilities are proven in a fractional dimension. The 2.2 dimension, this is a stable system. You say, what's that? I have to grow a little bit to study to know about what is known as non-linear dynamical system. And this is the beautiful picture, the blue pale dot, right? Suppose, imagine, so how much time do I have? Are you getting bored? Well, if you are getting bored in general, then I will stop. But I have nothing, no vested interest. Right? I'm having fun talking to you. Suppose, imagine, in a rocket, you have been dropped near the rings of Saturn. Nobody else. And then you meet a Mr. or Mrs. Alien. I do not know what is an alien. Suppose. And then alien asks you, who are you? What answer you will give? You can say, I'm a human being. There is not nobody. How to define a human being? So what you have to probably say, you see, sir or madam, depending on Mr. or Mrs. Alien, you see me, 780 crore, 7.8 billion like me, and millions of other forms of life, all rivers, mountains, oceans, sea, everything is concentrated in this dot. Now you see how important you are. When you look at the mirror, each one of us, from this distance, you have to tell, you see that dot now? I'm a micro dot in that dot. That is mine. Be humble. Be proud of only one thing in your life, your knowledge. Nothing else. Not your parents' money, not your house, not your car. Be proud of your knowledge. That's the only thing that makes us big. We are micro dots, right? But don't forget, 25 to 30 centimeters, we can see the image. This is the most precious part of our existence. So we hard okay. 1801, Italian astronomer Giuseppe Piazzi discovered a piece of rock typically 900 kilometers in diameter between the orbit of Mars and Jupiter, named it Ceres. People thought a new planet has been discovered, but within a couple of years, 3 more, Pallas, Vesta, and Juno, each around 500 kilometers in diameter, were discovered in the same region going around the sun. People realized a new class of object is getting discovered. And starting from 1801 till today, thousands and thousands and thousands pieces of rock, 100, 5, 20, 29 kilometers in size, go around the sun between the orbit of Mars and Jupiter. They are called asteroids. This is a true representation of NASA, not a cartoon. Here, each green dot is a discovered asteroid. They have a names, each green dot. Imagine this special type of people in our society call themselves astrologers. 9 planets, maybe sun and some other thing, 10 fingers, 10 agotis. What they will do now? And from the tip of your hair to the tip of your toe, you have to wear agotis to make them all happy. That tells you what nonsensical things their predictions are. That is the whole point. But these red dots are important. These red dots, they are called Apollo asteroids. What are their speciality? Their orbit intersects the orbit of Earth. That means Earth is going around the sun. One of them can come at the same point, same time, hit. The collision that will occur, my friend, 1/5, 1/6, 1/7 of the Earth will work. Forget about you and me. I'm here smiling. Next moment, my smile will be there. I will not be there. Evaporate. The heat will be so much. When can it happen? If you don't believe me, go to the internet. Any point of time, it can happen. As I'm giving this lecture, at this instant, it can happen. It can happen 10 years later. It can happen 10 lakh years later. Nobody. That we are alive is accident. So use your every moment of your life fruitfully, happily, the way you want it. Just to give you an idea, forget about the asteroid. 3 years back, 2019 December, 25th December, 31st January, December 1st January. Can any one of us thought that coming 2 years, how it will happen? Facebook, Happy New Year. Almost all of us got 15, 20, 100 messages. It was the Happy New Year, New Year. That is the example you should. It's a lesson. You may think it is happy, but it may not turn out to be happy. So use your every second. Kal ho, aaj chhod do. Aaj ka kaam, aaj. That will make you a better, balanced person. Spacecraft has landed on the surface of an asteroid called Ryugu. Spacecraft name was Hayabusa 2, a Japanese spacecraft, and it has brought back the sample because now they think huge amount of mineral-rich deposits on the surface, which can be used for future human civilization. Are there 9 planets in the solar system? Starting from 1998, mainly 3 scientists from Geneva Observatory, they started discovering newer and newer objects at the furthermost point of our solar system, going around the sun. Funny names: Sedna, Quaoar, 2004 DW. Most of them were close to the size of moon, right? But they're going around the sun. So people started asking, if you're calling Pluto a planet, why can't you call these objects a planet? And if you don't want to call these objects a planet, why are you calling Pluto a planet? Big noise. And in 2003, 16th November, this was discovered. Initially, the name was 2003 UB313. Now the official name is Eris. Bigger than Pluto. Takes 557 years to go around the sun once. Pluto takes 248 years. Bigger than. Now what will you call? 2006, Around 3,700 astronomers met together in Hague, meaning Holland. I have also been an associate of the International Astronomical Union, the highest body in the world to decide everything on astronomy. There, what is the finding? Believe me, for 3 days, the debate was so bitter, almost physical fight. What is a planet? What is not? And sometimes science also takes funny routes. After 3 days, 3,700 astronomers could not come to a decision whether Pluto is a planet or not. As a result, voting was. Science, you believe in one, others believe in another. And by voting, it was decided Pluto is demoted from planet. Critical things happen in science as well, right? But now there are 5 dwarf planets. Initially, there were 3: Pluto, Ceres, the largest asteroid, these 2 rather. And this, when Eris was discovered, it became a dwarf planet. And in 2015-16, 2 more has been officially incorporated, called Haumea and Makemake. Makemake is the name of an Indonesian god. 2006, NASA started a slogan, follow liquid water in our solar system. Every drop of water is life. Mars, possibly yes. Any other? Yes. One of the big moons of Jupiter, Europa, they found these sort of scratch marks. Then they realized the surface is made up of 15 to 20 kilometer thick water ice. Inside, there is a deep reservoir of warm liquid water. This water from the inside is putting pressure, cracks are occurring on the surface. And these are the cracks. That it is true was proven in 2016 when a spacecraft called Cassini was passing over one of the moons of Saturn called Enceladus. They found hot water geysers, Ushno-Prostrobon, coming out. Do you know what is the estimate of amount of liquid water inside Enceladus? 1.2 times the fresh water on Earth. So much water, no life, you want to say? My friend, life is a universal process. It is not particular to us. Don't think, "Arey, hum log ko dekho." Living, koi hai but abhi tak hum log ko mila nahi. That doesn't mean life is not. So, 2024, this machine, instrument called Cryobot, is going to be sent to both Europe and Enceladus. And 2029, opening the newspaper Telegraph Times of India, you'll see discovery, life has been found in Jupiter, Moon, and Saturn. And don't think those lives are always very friendly with us. They can be funny also. So it's an exciting. Out of the solar system, all true color pictures of the sky. Twinkle, twinkle, little star. You will say, what nonsense? When I look up in the sky, 2 dots, stars, and nothing in between. How come you are saying these are the true color pictures? Do you know why we don't get to see this picture? The problem is with the human eye. Human eye has something called perception of vision. Within 1/10 of a second, whatever amount of light enters through our pupil and falls on the retina, the optic nerve immediately takes them to the back of our head, because our brain, this side is called the optical lobe, and creates an image. So we see actually from this region of our brain. Right? Our eyes cannot add light, integrate light like a CCD chip. So if our eyes were like a CCD chip, looking in a particular direction in the sky for 10 hours, 20 hours, you should have seen millions of stars and all colors, gas clouds. But when we see totally dark black, problem is. Are all the stars like the sun? Answer yes and no. Why yes? Most of the stars are burning hydrogen to helium at the core, but why no? They come with different initial mass, different surface temperature, different chemical composition. In terms of mass, typically 0.8 to 150 times the mass of sun is the range of the stellar masses. Typically solar mass is 2 × 10⁻³ kilograms. In terms of temperature, 50,000 degree surface temperature to 1800 degree. Central temperature is 1.5, but surface temperature may be different. And depending on the temperature and also chemical composition. It was a legendary lady, a woman, at Harvard Smithsonian Astrophysical Observatory almost 110 years back, created a classification scheme. The hottest surface temperature, O star, next star, B star, A star, F star, G star, K star, M star. 100 years, science has totally changed, but nobody can touch a classification scheme. Sun with a surface temperature of typically 5,600 degrees centigrade is called a typically G type of star. What can we learn by analyzing starlight? Lot. Suppose one of my young friends over here, I request them to give their ID card with a photograph. Imagine, looking at a photograph, I have to tell what is the weight of this object? What is the temperature of this object? What is the chemistry of this object? How long ago he was born? Without seeing the numbers, just the photograph. Is it possible? But don't forget, looking at the light coming from a star, you can answer all these questions. The only thing needed, buddhi. Same light. Actually, this is not the real light coming from a body. This is reflected light. If you see me in infrared, you can talk about my mass, density, chemistry, temperature, evolution, meaning age. This is where science is. Just by one. So it's a tremendously challenging. And that brings me to the life and death of stars. Stars are born from interstellar clouds of gas and dust, which we generally cannot see with our naked eyes. And in the sky, there are regions. We want to see true color pictures. True. 1,000 solar system will form out of it. Don't mix it with the clouds that you see in the sky. You want to see. Amazing. But 2.5 million pixels, one image. Each pixel will give you information. Just to give you an idea, 10 to 12 PhDs come out of single photographs, one photograph. Greenish blue, oxygen 5, oxygen 6, blue, neutral hydrogen, yellow, sulfur, black, iron, green, zinc or molybdenum, white, titanium. A picture tells us. That's how you find out. Painstaking, backbreaking job. Believe me, 3 to 3.5 years, your whole life goes out if you are focused on it. I'll give you my example. I did a PhD in an institute called Pune. In Pune, not an institute called Pune, called IUCA, Inter-University Center for Astronomy and Astrophysics. I was the first student of that. My supervisor was one of the fascinating personalities called Jayan Jishnu Narlikar. You may have read about it. Institute was in Pune. One time, after 3.5 years of my PhD work, when my PhD I submitted and instantaneously got appointed in TIFA, Tata Institute of Fundamental Research, I went to the Pune bus station and bought a Pune Darshan ticket to see it. After 3.5 years. Believe. If you're serious, 12 to 13 hours per day, nothing enough. You have to put in that. Shortcut doesn't work in life or success. So we are made to believe shortcut works. If I know any political data, doesn't. So tremendous backbreaking job. Think about this. Just to give you an idea of the size, you see these dots over here. Each dot inside has a fully formed solar system. If you are born, you have to die. How do the stars die? Stars die differently depending upon their initial masses. If the initial mass is 1 to 8 times that of sun, for example, take sun. It is burning hydrogen to helium at the center. How long? 500 crore years. After 500 crore years, all the helium, all the hydrogen at the center will get transformed to helium. The thermonuclear fusion reaction stops. Energy generation stops. Outward pressure stops. Gravity is there. Sun becomes smaller. As it is becoming smaller, And the outer envelope, huge amount of hydrogen still remaining. Because of contraction, the temperature rises and slowly it rises to 500 crore, 1.5 crore degrees centigrade. At that temperature, hydrogen burns to helium. What was happening at the center? So helium is produced, energy is produced, heated up, becomes big. So after 500 crore years, if you open the window, you'll see sun becoming smaller and smaller and smaller. Suddenly it will stop and it will start becoming bigger and bigger and bigger. How big it will be? In a small calculation, it can be shown. After 500 crore years later, sun will become bigger and bigger and bigger and ultimately touch the orbit of Earth. Yes. Mercury, Venus, Earth will long before become a part of the sun. End of the story. At that time, the star will be called the red giant. Over millions of years, as it goes on, is it becoming bigger, inner core becomes smaller because of gravity. Helium contracts, reaches a temperature of 10 crore degrees centigrade. 3 helium nuclei fuses to give rise to a carbon nucleus. Again, generation of energy stops. But soon, when all helium goes on to carbon, the mass is not enough to produce more pressure to raise the temperature to 100 crores, 10,000 crores. So stops at carbon, very hot. In the sky, like a dot, it will become shine, will be called a white dwarf. By that time, the outer envelope has become so big, it slowly starts getting detached from the central region and is called a planetary nebula. Nebula, the word means cloud. Nebulizer, you use it to make a cloud of the medicine in your face. So nebulizer, nebula, right? You think it's a funny story, right? After millions of years, the white dwarf will dissipate away the energy and will become a brown dwarf. End of the story. No. You tell me, my friend, inside the Earth, under tremendous amount of temperature and pressure, carbon gets transformed to what? Diamond. Scientists in the last 30 years have discovered 15 to 20 kilometer piece of diamond floating in the sky. On the Earth, ladies fight for 1 carat. That's the smallest dot of diamond, right? 15 kilometer piece. Our sun will probably end its life like that. You think I'm telling a story? True picture of planetary nebula. For the last 35 years, 30 years almost, my small research is on these fields. How the stars become bigger. It pulsates. And every time it releases a shell. So before coming to Kolkata, I was a faculty at University of Manchester. The group was there and still there. Basically, we find out the shock generated amazingly can produce molecules, which nobody even imagined earlier that can be produced, right? And a vibrant branch of chemistry called astrochemistry or astronomy called astrochemistry. But these works started, in my case, 93, 94. Most of you are not born at that time. Right, so these are the molecules we have simulated in the computer and has been discovered. And you see organic molecules which can produce life. Any star at its end phase can produce the raw material for life. Death of stars, stars which are huge, 8 to 25 times, hydrogen to helium at the center becomes smaller, temperature rises, helium to carbon, mass is more, again smaller, carbon, oxygen, neon, silicon, sulfur, it ends with iron. Iron is the maximum, highest binding energy. You cannot fuse iron nuclei to form bigger nucleus. It ends there. Layers like peels of an onion, hydrogen, helium, carbon, oxygen inside a ball of iron. And this is which all the layers, because of gravity, falls towards the iron core. Poor iron fellow has nowhere to go. It becomes incompressible. Bang onto it. Gets a recoil. Tries to come out, explodes. A supernova explosion. And the point of explosion, starting from iron 56 atomic number, mass number, to 94 in the periodic table, all the naturally occurring elements get exploded in a fraction of time. Right. So, inside of the star, when it explodes, a supernova explosion, and I don't have much time, I have taken much longer. Believe me, each atom of iron in your blood, in my blood, each atom of calcium in my bones, sodium, potassium, zinc, Whatever my body is made up of, atom by atom, if you ask the question where from it has come, the answer is these elements, apart from hydrogen and helium, can only be produced inside a star and thrown out by the supernova explosion. So, my friend, you, me, this table, anything, this computer, we are made up of stardust. We are all stars. So, this is the fascination. Just 1 minute. This is the fascination starting from cloud, ends up in the cloud, but a lot of chemistry, astrochemistry happens. And when the question of life cycle of gas and dust occurs, we find almost every element in the periodic table is produced in astrophysical context. And so when the life in the universe question comes, are we alone? How did life occur on Earth? The answer is life never started on Earth. Just like that. Elements, not aliens, elements, molecules came from outer space, reacted with the atmosphere, environment, and lifespan. So we are all part of the cosmic dust. I will basically end my story here because I've taken a lot of time. So hope someday, somewhere, we'll again meet and talk about this fascinating subject of black holes, but not today. Thank you.
Thank you, sir. Thank you for taking us to the stars. I will now request Satpathy sir and Monali ma'am to felicitate sir.
And forget about it, the mic. For the students, thank you very much. It's the only thing I can say. Each one of you were so bright, so attentive. I'm almost emotional. Who says nowadays students don't get involved into other things, only studies? It was an exception. Wonderful for each one of you. The best of your success, the best of your life is there. Take it. Have a wonderful life. Thank you very much.
Next, we will hear it from Dr. Arnav Chakraborty. He's currently working as an associate professor in ISI Kolkata. He is keenly interested in popularizing science education using Bengali, retaining the technical terms in English. He has authored about a dozen math books in his Banglaয় Bojhano Ingraji Boi series, implementing this idea for +2 level and undergrad students. Today, his lecture will be on mathematics through puzzles.
Okay. So it's customary to start any such lecture by thanking the organizers, etc. But now I can only thank one thing: the accident that caused us to be here. So with that, I will just start directly. Now, since we have learned so much about the outer space and the Earth and the Moon and the planets, etc., billions and trillions, and etc., so I will start with something which has to do with the Earth. But since I am doing puzzles, this thing is really not astronomical. It's just a simple puzzle that was introduced by the famous American puzzlist called Sam Lockwood. Now this one just tests your ability to count. So can anyone please count how many of those people are there around the Earth? Just count 1, 2, 3, 4. 12, okay. And yes, please get up, please get up. Some of you are sleeping, I have seen them. So I've got 12, right? Fine. Now look very careful. So when this piece of puzzle was sold, it came into two parts. So you have an outer square or rectangle made of a cardboard, and the inner circle, the art part, was a separate cardboard disc. Now what you do is you turn it. So look very carefully. I'm going to turn. Step 1, step 2, step 3. You see, nothing came from any hidden place, nothing went behind something else. Can you please count the number of people once again? So that's puzzle number 1. How come we had only 12 people and we have got 13 people? Now, of course, that's not really much of a magic, because the way population grows, we all know that things just increase. But that's not how population increases. So can you explain here what happened? Anyone? And then I will talk about its mathematical implications and all that. What happens? I'm just doing it a number of times. Everything remains visible all the time. Nothing comes from outside and nothing goes into outer space. Nothing comes from the stars here. Any clue? Just think of it as a class. You can answer, you can stop me, no problem. Is it 12 or is it 13? Or is it 12 is equal to 13? 13? And now it becomes 12. So 12 equals 13, which means 1 equal to 0, and all your math problems are solved, right? If 1 equal to 0, you can prove that all your math problems become 0. Then everything is equal to everything. Any explanation? Yes, please.
So the lower one.
The lowest time, okay? So this fellow. Okay?
So the left one.
This one.
Yes.
Okay?
So when he is going to the top, I think it's becoming 2 fellows.
That guy is becoming 2 fellows. Let's just see. Oh, sorry. Is he becoming 2 fellows? No, it doesn't seem like that. That's 1. So he just
Still in the same line.
he's just facing this guy now. That's the one fellow there. And we are counting them separately. And earlier also we are counting them separately.
Yes, sir, but the leg portion.
So he has found something. You see, that leg portion, part of it, I said nothing is getting hidden. Well, that's not entirely true because part of his face is actually getting hidden behind that guy. Okay, so you have found out one little flaw here. A little part of a leg is missing. Yes, very good. But a human being is not just made up of leg. Yes, he can explain the leg. What happened to head? What happened to chest? The hands? Why did I smuggle it off? But he has the right idea. There is a sliver of a leg which you could detect. Somehow, slivers of the other parts are also getting reshuffled somehow. Hand. Someone can figure out the hand.
The first one, on the top one.
Okay? This guy.
The time before that.
Yeah, this one.
Yeah.
And you can see part of that. Yes, so now you are starting to get the hang of it. Now, one beauty of mathematics is when you are faced with some puzzling situation and you believe that something ought not to be the way it seems to be, in that case, it always helps to look at the same thing in an abstract way. And that is the greatest message of mathematics. Abstract it out and life becomes much more easy. What I'm going to do is I'm just going to abstract it. Very trivially, I will remove this circular thing, I will remove all these pictures, etc. It will possibly become a bit prosaic, but much more easy. So here it is the same thing, but from a mathematical perspective. I again have a card. This time the card is a much simpler thing. It is cut along that slanted line, and I have drawn instead of some paper, some vertical lines. Now I'm going to do the same thing. I will count. How many lines are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? I'm sliding it. Just look. I'm sliding it like this. And you can immediately see that the number of lines has become 12. Is there any magic here? If you show it to someone, no one will say there is any magic. Because you quickly recognize that all these 12 lines are a little longer than the original 13 lines. So the thing that shocked us is I just turned something around. How can the number of people change? You believe that the number of people is supposed to be invariant. What is invariant is the amount of ink, the total length of the line. That is the thing which is supposed to be invariant. And indeed, it is invariant. It has not changed. I've just redistributed them so that when you have a smaller number of lines, each one of them is actually slightly longer. Here, when I have laid it bare in an abstract way, everyone can see it and there is hardly any magic. But the moment you do it camouflaged in all those little pictures, things get rather tricky. Now that is an important thing. So first of all, abstraction is the greatest beauty of mathematics. And it also takes us to a very important principle that I'm going to devote most of the time here. That's called the principle of invariance. But before that, when I first learned this, I was in school. I got it from some magazine, I think, Anandamala or something like that, where I got it. Of course, they did not explain it in any of these things. So they just gave the puzzle. So I just cut out the page and saw that it works in this way. And then I wanted to create something of my own, which is a pretty good habit. Whenever you say something, try to make a copy on your own is actually a nice thing. So here is something that you can do. So what you do is you start with 2 strips of paper. Just 2 strips of paper that you can slide. So you take a full page, slice off one end so that you can slide it along the other. Slide it like this, like this. You can slide it. And then, depending on your ability to draw, I can only draw stick figures. I drew a stick figure like this, with the entire part on the upper strip, with a little bit, a sliver of a foot on the lower strip. And then you slide. Okay, so the little sliver of a foot comes to the right, and this guy, well, is almost like an entire fellow because this sliver of a foot for a cartoon picture, you hardly know. Okay, now what you do is you complete that little foot. You just add another stick together with that as a foot. Well, you slide it back, and then you endow that fellow with somewhat longer. And then you slide it back again and draw another. Slide it back and give him some longer. So the idea is you are drawing a sequence of figures such that they start from the top and slowly start making their way down into the lower. You keep on doing this, make little imperceptible changes in each one of them and go on like this until you come all the way to the end. And you have your own little magic. I became very popular at school making. So you just count how many are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, I will slide. And let's see how many are there. Count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And you can see I have cheated in a slight way. This guy is missing his feet. You hardly see this. That guy, if you move around, you can see has left the top of his head separate. Top of his head is there. But since these are all cartoon figures and you can hide them with these kinds of texture and some cloud and birds, etc., it is quite easy to cheat. And if you want, you can make 100 pictures. Each one of them will be 1/100th of a part different. So if you make it a much more high resolution thing, no one will get it. So that was fun. So if you want, you can make it on your own. I always like to make things on my own. But in the meantime, the thing that I am going to talk about is the principle of invariance. Something that does not change. That is a very basic principle underlying many things in mathematics. So we learn mathematics like here's algebra, that's geometry, that's trigonometry, but not the basic underlying principle. So invariance is one of those principles. When you face a problem, you do not know whether it's geometry or trigonometry or whatever, but something should not change. If that thing changes, that rings a bell. And using the fact that this thing should not change, you can solve lots of interesting problems. Now I'm going to give you some taste of those things. So taste of invariance. Now there are lots of different things that we can. That's some funny design I can see over here. Oh, I think it is there. That little piece of string. Okay. So this thing is called the 15 puzzle. Again, another thing which was made popular by Sam Lloyd. Actually, he stole it. The idea was someone else's. He marketed in his own name. Sam Lloyd was a great puzzleist, not a very scrupulous one. Now, the 15 puzzle is something that we have all seen. Maybe you do not know it by this name. It is sold in every toy shop in Kolkata. So it comes as a little tray with lots of tiles in them. There are 15 tiles to be precise. And they have this number 1, 2, 3, 4, up all the way up to 15. One place is left blank. What you do with them? You can slide the thing like this. You can slide that 8 to the left, and you can move the things around. You can similarly now take the 11 up, then take the 10, and etc., etc. So you can move them around. You are never allowed to lift any of the tiles off the tray. When Sam Lloyd first sold it, it came packaged like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 14. So 14 and 15 came first. The challenge was you have to keep on sliding, sliding, sliding until you set it back to the proper one. So 1, 2, 3, 4 up to 13 should remain again finally in the same position, but 14 and 15 should come into their proper order. And he sold this, and it was 1860, and he declared something like a $500 price. At that time, $500 price was a big amount. It is still a big amount. So whoever can solve it first will get that prize. Sam Lloyd was a great guy for popularizing something, and this was his business trick. People started to buy it all over the place, and many of them claimed that yes, we can solve it, yes, we can solve it. They went to Sam Lloyd, but none of them could really do the thing in front of Sam Lloyd. So no one got any prize, and one day Sam Lloyd passed away. Then later, after Sam Lloyd passed away, some mathematician looked at it carefully and figured out that the thing can actually not be done. Now, we do not know whether Sam Lloyd actually knew the thing. He claimed that he could solve it, but he has never shown his solution. Maybe he was just lying, not being a very scrupulous fellow. That's quite possible for him. Or maybe he had a wrong solution. But how do you show that this is not possible? That is a very good application of the invariance principle. Now, invariance principle is useful when you want to show that something cannot be done. If you want to show that something can be done, you can just try and try and try. Possibly after 1 month's effort, you get the solution, show it to everybody. Everyone is convinced that yes, you can do it. How do you prove that it cannot be done? You may say, I have tried for 10 years, I could not do it. That does not prove that it cannot be done. It only proves that you could not do it. Your friends could not do it. Maybe someone else after half a century will be able to do it. So can you prove that you cannot do it? These are all sort of big results in mathematics, that you cannot do something. Now, I'm going to show quite simply that you can never move from the start configuration, that is what, to the end configuration. Okay, let's see. So just listen to this with just in the mood of a puzzle. It's not going to be great mathematics or anything. Something that you should be able to understand without having to scribble anything. Okay, so I have to go from here to here. Let me ask you the simple question. Can you solve the problem in exactly one step? The answer is obviously no. Why not? Because in the first step, I have to move it, right? I have to either do like this or I have to do like this, in which case the blank space will move out. In the final configuration, the blank space should again get back to the original position. So in one step, I can do it. That's very tricky. Can you solve the problem in exactly 3 steps? You can't. Why not? Why not? Yes, please.
So after any odd number of steps, the blank should return odd. Should be at an odd number of positions away from it.
Okay, yes, you are basically getting the right thing. So you cannot do it in 3 steps or 5 steps or in any odd number of steps. And why is that? Because suppose someone can solve it, which means this blank space will travel all through the space and then has to return back to this bottom right hand corner. Which means count the number of times it has moved left. That must exactly be equal to the number of times it has moved right. Because it has to come back to the same place. Count the number of times it has moved up. That must be exactly equal to the number of times it has moved down. So number of left equals number of right, number of up equals number of down, which means it has to be twice the number of times it has moved left plus twice the number of times it has moved up, because it has to also come back rightwards and downwards. So if the puzzle can ever be solved, you need an even number of steps. You can never solve it in an odd number of steps. I'm not saying you can solve it in an even number of steps, but odd number, it is clearly impossible. You cannot even bring that blank place to the back to the same place. Okay, so that is something. I at least ruled out half of the possibilities. Now, I am going to get into that invariance principle, and this shows how quite abstraction helps. I am going to do a very strange kind of abstraction. Whoever thought about it first was the clever. It's not difficult, but it's brilliant. What I will do is, I will imagine that all these little tiles are people waiting in a row. So like 1, 2, 3, 4, etc., etc. So I am just writing them out row by row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 4, 13, 15, 14, and the blank thing I will call 16. So I'm just writing them row by row. First level of abstractions. Forget about that square structure. Okay. Now, when you move, when you make a move, like you put the 12 down, slide the 12 down into the position 16, what happens? Everything else remains wherever they are, but the 12 goes to the place of 16, and the 16, 15 means the blank, that comes to the place of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, blank, that is 16, 13, 15, 14, then 12. So just the 12 and the 16 get swapped. So every move is nothing but a swap. Now, I am doing that abstraction. I will just imagine that all these numbers are people standing in a queue. They're all waiting in a queue, pretty bored guys. And the numbers that you see, they actually denote the duration of wait. So this 15 means this guy has been waiting for 15 minutes in a queue, and this 2 means he is waiting for only 2 minutes. And they're quite confused you because you can see that they are not in the correct order. So this guy is waiting for only 2 minutes. How come he is standing in front of him? So this is the kind of queue that you actually see in Kolkata. So it's completely random. So whoever can sneak in anywhere. Now as a result, whenever you see any such queue, people get angry, they start shouting and fighting. So you have unhappy people. Say for example, they are very unhappy. This lady is very unhappy because she says that I am waiting here for 16 minutes. How come this guy who is waiting for only 9 minutes is standing in front of me? So that pair is an unhappy. Similarly, that is another unhappy pair. This old gentleman is shouting because I am waiting here for 11 minutes and this guy is waiting for only 4 minutes. Why is he standing in front of me? So that's an example of an unhappy pair whenever a small number comes to the right of a large number. And of course, we also have happy pairs like this guy. He's quite happy because he says that, well, I'm only waiting here for 2 minutes and this guy is waiting here for 11 minutes. Only natural that he should be in front of me. I do not know. So that's the happy pair. So given any pair, it is either an unhappy pair or happy pair because all the numbers are distinct. Now let's quickly see whether we have really grasped the idea. I have this, a little exercise. This fellow and this lady. Are they happy or unhappy? They are happy, right? Because 9, I am waiting for 9 minutes and she is waiting for 6 minutes. No. They should be happy or unhappy? Unhappy. They should be unhappy. What about this? I am waiting for 9 and he is waiting for 11. They should be happy. Right. So you now get the idea who are happy or who are unhappy. Now I say that these are actually my tiles, and whenever I move, what I am doing is I am basically swapping 2 things. Whenever I am sliding one of the tiles, I am essentially swapping. So let's see if I swap how the total number of amount of happiness changes. We are going to explore. So let's take this. Suppose I am taking these 2 fellows. This fellow who is waiting for 9 minutes, and here is another guy who is waiting for 5 minutes, and I am going to swap. Everyone else remains in the same place, and I have swapped. Now let's see what happens to the amount of happiness. You understand, the guys who are standing behind, they don't care. Because 2 guys swap places in front of me, why do I care? So the same number of guys are still standing in front of me, so they do not care. Similarly, these guys do not care because something is happening behind their back. They do not care. So the people who are possibly caring are these guys. Now let us see how these things change. Suppose I consider between any 2 things. Obviously, there is no change because if they were originally happy, they are still happy. If they're originally unhappy, they were still unhappy. So nothing changes between them because they are still wherever they were. Things can only change in relationship to these 2 people who have changed things. And how is that going to change? These things must change. Say, for example, I consider this guy with this. He was earlier here. So he was standing in front. So if They were happy earlier, now they must become unhappy because we have moved it behind. Similarly, if they were unhappy earlier, now they must be happy. And same thing is true here for these two. If they're originally unhappy, now they must be happy. And if they're originally happy, now they must be unhappy. Each of them must change. Is that clear? Each one of those things must change. So, how many people are there in between? There are five. Irrespective of five or whatever, 2 times 5 changes are there. Why 2 times 5? From the perspective of this guy, I will have 5 pairs. 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs. They have changed. For the same 5 people, I have pairing with respect to that guy. So another set of 5. So 2 times 5 changes are there, which by the way is an even number. Irrespective of whatever is the intermediate number, even if it is something else, it is 2 times that. Plus, there is one other change. Can anyone identify what other pair must change? Between the two people. The two people who have swapped places. That also must change because the order has changed. So the total number of change in happy pairs must be an odd number. Because it is 2 times whatever the central thing, that's even plus 1. That is the main message. If you look at it from the viewpoint of that box, is a 4 by 4 structure, then it is quite difficult to see this. But once you make them stand in a row, this becomes much more accurate. So we can see that for every 2 squares, the parity of the number of happy pairs and also the number of unhappy pairs must be an invariant. Because if it is odd now, in the next step it must be even. In the step after that, it must again be odd. So odd, even, odd, even, odd, even. So after every 2 swaps, you come to even, to even, to even, to even, or odd to odd to odd to odd. So that is something which is invariant. Howsoever you play the game, that is one thing that cannot change. And now you already know that when you play the game, if you succeed in solving it, you must be using even number of moves. So you just look at the 2 configurations. So initially, the number of unhappy pair was exactly 1. These 2 things were the only unhappy pairs. And there, what was the number of unhappy pairs? Can anyone tell me what is the number of unhappy pairs in the second thing? 0. Because everyone was standing in order, and 0 is an odd number or even number, or it is neither. How many of you think that 0 is neither even nor odd? 1, 2, 3, 4. And these 2 are half raised, so half. Okay. So for you, there is a very good news. 0 is an even number. I've seen it being taught in schools that 0 is neither even nor odd. No, 0 is an even number. Simply because 0 can be expressed as 2 times 0. 2 times an integer. Anything that can be expressed as 2 times an integer is an even number. 0 is an even number. It is not undefined, it is not indeterminate or anything. Either it is even or it is odd, and it is even. So initially, you have number of unhappy people was odd. And finally, the number of unhappy people, unhappy pair is even. We have just now said that howsoever you move, you can never change the parity of unhappy pairs. You must always, since you started with odd, the total number of unhappy pairs must remain odd. In this case, you are to go to somewhere where it is even. So it is impossible to solve the problem. So the main idea is the idea of invariance. I do not mind if you not follow all the arguments, except that something did not change and that quantity needed to change in order to solve the problem. That's how we solve it. The details you might forget for the time. Okay. So that was one thing. The number of unhappy pair was 1 and the number of unhappy pair was 0, so it is not 1. Fine, that's enough for one topic. I do not, of course, I can go on this topic of invariance. It's interesting, but for the time being, let's just get to another thing. I think I do not have much of a time, so I will just skip to something more. Can anyone tell me what is 2 plus 3? 5. No, everyone knows that. Someone even says 5. So I can see 5. Good. But you are wrong. 2 plus 3 is not equal to 5. I'm going to prove it. I will prove it. I will prove that 2 plus 3 is either equal to 6 or it is equal to 100. Yes, I'm going to prove it mathematically, following exactly the rigorous steps that you learned in your text. And this is how I start. I will start by writing 3 steps. I've written 3 statements. I'm not claiming they are true. Being a free citizen of a free country, I can write whatever I like and I will. The first statement is 2 plus 3 is not equal. The second one says 2 plus 3 is not equal to 100. And the last statement is at least one of these 3 statements is false. I'm not claiming that these are true or false or anything, merely written down. Now these 3 statements, as we all know from our logic books or whatever, they are either true or false. Everything is either true or false. As long as it's a nice assertive statement, it is either true or false. So let us see whether these are true or false. I will start with the last step. And my question is, can C be false? Can C be false? Well, my argument will be like this. Suppose C is, if C is false, what does this mean? It says at least one of these 3 statements is false. If that is false, that means all the 3 statements are true, right? For example, if I say at least one student present here is a girl, and that's false, that means everyone present here is a boy. Similarly, if C is false, it should mean that all the 3 statements are true. Well, if all the 3 statements are true, in particular, C itself becomes true. So if C is false, then C is true, and that's meaningless. So I must understand that C cannot be false. Because if C is false, then C becomes true. That's not possible. So C is not false, which means C is true. Fine. So C is true. Great. What does C say? At least one of these 3 statements is false, and I have already seen that C itself is true. So one of these must be false. So at least one of A and B must be false. If A is false, that means 2 plus 3 equal to 6. If 2 plus 3 not equal to 6 is false, then 2 plus 3 must be equal to 6. Or if 2 plus 3 not equal to 100 is false, this means 2 plus 3 must be equal to 100. So I'm not saying it is whether it is 6 or 100, but either it is 6 or it is 100. It cannot be 5. 2 plus 3 is either 6 or 100, and I proved it. You cannot deny, I just proved it. I just wrote 3 statements. I had every right to write them down. I actually argued that C cannot be false, so C has to be true. And immediately it came that 2 plus 3 must be 6, or 2 plus 3 must be 100. So I proved it. And you thought that 2 plus 3 equal to 5. Can anyone tell me what's wrong? Yes.
So, I think like for option C, right?
Yeah.
So C isn't true, right?
C isn't true, right?
So we are assuming the existence of C as a condition, but that condition can't exist.
No, I have just stated it. I have shown that C cannot be false. I just written it. It is either true or false. I did not claim that it is true.
Yeah, but
I
then
proved.
like that condition can't exist at all. Like,
Well, everything is either true or false. I just written it down, so let this thing right on the board.
like, it becomes a paradox. So if it's true, it's false. But if it's false, it's true.
No, that is not true. If it is false, then it is true. But if it is true, then it is not false. It is not both ways. Just only one side is not wrong, and that is why I said it cannot be. So only one side causes the problem, so I removed that. But it can be true, not a problem. But yes, you are of course on the right side. C is the culprit. C for culprit. Because that's why I was this weird kind of thing. You have seen statements like A and B. C looks weird. Yes.
Sir, and to say that at least one of this false, that doesn't mean that all of it can't be false.
No, I said at least one of these is false. So if that is false, that means all of them have to be true. So at least one is false. So, so exactly which part of the thing you are talking about? About the proof that can C be false. You are arguing about that?
No, I'm telling that at least one of this is false.
Okay,
So two can be false also.
right, of course. A can be false or B can be false. If A is false, that will mean 2 plus 3 equal to 6. If B is false, 2 plus 3 equals 100. One of them must be false.
Both can be false.
Both can be false also. 2 plus 3 equal to 6 as well as 100. That is also a possibility. Yes, I'm not ruling that out. That is also possible. But of course, that is also quite mind-boggling. How can 2 plus 3 be equal to 6 as well as 100 simultaneously? So that is also part of my proof. So I'm just proving something which is nonsense. Right? So obviously that also remains nonsense. Yeah. Yes. Right. So she says that actually they cannot be true simultaneously. And for that, you have to bring in extra considerations like 6 and 100 are not same. So you cannot be equal to both of them simultaneously. Right. But so what I can say is that at least one of A and B must be false. With that extra consideration, I can say exactly one of them must be false. But in either case, 2 plus 3 is not equal to 5. I'm proving that. Right? I at least prove that. So what is going on? And incidentally, this puzzle is created by a very famous, I think he's still living, very old, mathematical logician. And if you're interested in recreational mathematics, he is one person whose books you must read. His name is Raymond Smullyan. So do a little Google search, plenty of books. And he's of course a famous mathematical logician, and he has created all these puzzles to explain mathematical logic. So they are not just a collection of random things. So this is so all these puzzles lead into deep mathematical theory. Now in this case, a problem, as you have already started to guess, with the statement C. Okay, so this is still the problem. In this statement is what is called a self-referential statement. It refers to itself. Now, whenever a statement refers to itself, that might lead to mathematical contradiction. So these statements are not considered valid mathematical statements. So this is a preset, as he was trying to say, this condition does not exist. And I countered him by saying, why? I have written it down. I have written it down as an English sentence. So the important thing to remember is that the grammar of mathematics and the grammar of English are different. You can write a sentence which is grammatically correct in English. That does not mean it is grammatically correct in mathematics. In mathematics, you are not allowed to use pronouns. You are not allowed to refer to something using a pronoun like be step. Such a thing might very well lead into confusion. If you want to have this clear idea, every statement is either true or false, that holds only when you are working with statements without pronouns. Now here is a much more blunter version of the same paragraph. It is called the liar paradox. This sentence is false. Well, obviously, it's a perfectly valid statement, English-wise, but not a valid statement, mathematics-wise. Is it true or false? This sentence is false. If you say it is true, then it is false. And if you say it is false, then it is true. The problem is, this is not a valid mathematical statement, though it is a valid English sentence. So when you translate English into mathematics, you have to be careful about it. Now I will end with a little puzzle, the puzzle of two twins. I am sure all of you have heard this puzzle, where you just meet a guy who either always speaks the truth or always lies, and based on that, you have to do something. This is a little twist on that familiar thing by Raymond Smullyan, and I think I should stop pretty soon. Yes, I will stop pretty soon. So we have got two brothers, two twins. They are absolutely identical, but to help you out, I have sketched them with brown hair and black hair, but they actually look perfectly identical. Now the first brother is an intelligent and truthful guy. He knows the correct answer to everything and answers truthfully. And the second brother is stupid. He knows the wrong answer to everything and is also a liar. So the first guy will actually know the correct answer and says the same, says what he knows. And the second guy always reverses the thing because he's stupid and then reverses it once again. And we are talking about only statements that can be answered in yes or no. So let's take this example. Suppose you ask, does 2 plus 2 make 4? The first brother, being intelligent, knows that the answer is yes. Being truthful, he says yes. The second brother, being stupid, he thinks no, 2 plus 2 does not make 4. The answer is no. But being a liar, he says yes. So you see, he negates it twice. As a result, both of them end up giving the same answer. Similarly, if you ask, does 2 plus 2 make 5? The first brother knows the answer is no and truthfully says no. The second brother thinks yes, it is yes, 2 plus 2 makes 5, but lies and says no. From this, I think you all agree that whatever yes or no question you put to them, both the brothers will always give the same answer. Agreed? Okay. Yes. Yeah, right. You are right. So being very stupid, he will say 2 plus 2 equal to 5, and also 2 plus 2 equal to 6, and also 2 plus 2 equal to 2. He is very stupid. So whenever the answer is yes, he knows the answer to be no. Whenever the true answer is no, he says the answer is yes. He is so very stupid, he doesn't even understand that if 2 plus 2 makes 5, how can it make 6? He doesn't even understand. Okay, very stupid. So the main thing is, whenever you put any question to him that whose answer is yes or no, if the answer is yes, he will think it is no. If the answer is no, he will think it is yes, and then he will lie. Okay. With that understanding, you all agree that if you put any yes or no question, either this guy or to that guy, they will always give the same answer. Correct? Not of not will always be the original thing. I am talking about only binary question, yes or no. Everyone is sure about that. Thank you. Now, one of these two brothers come up. You do not know who he is. You have to put only a single question to that brother. The question should be answerable in yes or no to understand whether this is the good brother or the bad brother. Is it possible? You have to ask only one question which has to be answerable in yes or no. Remember, whatever yes or no question you put, we have just now agreed they will always give the same answer. One guy will say the direct thing and other guy will negate it twice, and as a result end up giving the same answer. But can you distinguish between the two brothers putting a single question? Yes.
What is the question is, are you truthful?
Are you truthful? Okay, so he has given this thing. Are you truthful? Now, even before I go into the details, can this answer really work? Because this is a yes or no question, right? Are you truthful? Either yes or no. And you have just now agreed every yes or no question, not of not, should be the original thing. So can his answer really work? What do you think? Both of them will actually give the same answer. But let's analyze this thing here. This is the thing. Are you the truthful brother? That is precisely what he says. Now let us say I come to the first guy. The first guy knows, yes, I am the truthful brother. For him, the answer is yes. He knows that. And he says yes. The second guy, of course, for him, the answer is no. But he always turns it around. He thinks yes. And of course, he lies. And now he says no. So here is an example where they answer two different things. So does this mean that not of not does not always give the same thing? We have learned minus of minuses gives me plus. Negation of negation should give me the original thing back. But here it seems to be a counterexample. Here is a statement, you negated it twice, you came up with something else. And what went wrong? Because again, we are using a pronoun. I use the pronoun you. So when I put the question to the first brother, the question was, is his brother truthful? When I put the question to that brother, the question was, is his brother is actually truthful? So I put two different questions to the two different guys. Because I used the pronoun you, and the you meant two different things in the two different contexts, that is why even fundamental concepts like double negation should cancel, minus and minus makes plus, those things collide. So in mathematics, we always have to avoid use of pronouns. If we use pronoun, that need not be a mathematical statement, and the idea that it is either true or false, or things like negation of negation should cancel, all these things need not hold. Okay, I think that's enough. The pronouns make different statements look the same. And if you are interested, here is another thing. So when I said that this sentence is false, again I use the pronoun. This sentence, it is referring to itself. Whenever you are referring to anything using a pronoun, that follows the false. Okay, I think I will stop here. But in case you are interested in just following up more along this line, this eventually leads to one of the most fascinating theorems in the world of mathematics. It is called Gödel's incompleteness theorem, which essentially works with a little modification of this. It says this result is provable. It can be proved. And there are lots of fascinating stuff. I will just mention that that theorem is considered to be one of the most difficult theorems to understand and to prove. Now, Raymond Smullyan has a wonderful book devoted to just that theorem, where he has presented the entire theorem as a sequence of puzzles. And the puzzles are actually not very difficult with all solutions at the end. And after you have solved all the puzzles, they fit together to give you a very beautiful proof of Gödel's incompleteness theorem. And the book is called To Mock a Mockingbird. So if you want, you can just do Google search, and that makes a wonderful summer project. So if you want to spend your summer in a wonderful way, you can follow. Okay, I think that's enough. We are running out of time. Thanks a lot.
Hello. Yeah. Thank you, Dr. Chakravarti, for the wonderful, exciting lecture. And I can see, I mean, all have enjoyed a lot. Now, may I request our Chief Librarian, Dr. Satpathy, to felicitate him. It's not felicitation, rather exchange of warmth. Thank you, sir. Now, next will be the quiz. When I communicated to you all the schools, actually I wrote that you need to nominate one person, one student from each school. So can I please request them to be on the stage from one person from each school? Or should I call the name of the school and then you come? Whatever. Okay. Adarsho Balika Shikhayaton. Someone from the school? Anyone is there? Or yeah, I think it would be good that one from each school come here, and then we'll call the rest of the schools. That will be lesser in number.
Central Service.
Govinda's girls. Govinda's Vidyamundi for girls. For girls.
Hello, hello. Hello, hello. Hello, hello, hello.
I'm from Morning Kolkata.
সিঙ্গেল না কৌশিকে একজন একাই যাবে ঠিক আছে ঠিক আছে ওখানে কি যাবে কর্তি বলে কর্তি ছুটি আছে
Is there anyone from Adorsho Balika Shikhayaton? No. Bardhaman Vidyarthi Bhavan Girls School. Depra Horimoti Saraswat Vidya Mandir. Bhavdhara BCS School. Bhavdhara BCS. Anyone? Future Hope. Future Hope School. Indus Valley World School. Sri Sri Academy. Anyone from Sri Sri Academy? Salt Lake School. Anyone from WWA Nashikpur English School? Anyone else? Any other school? Yeah.
Any other school which is not represented over here? Any other school student? Raise your hands. If anybody's school has not been represented over here. If you are here, then come to the front here. Anybody is there?
I'll just read out the name of the schools who are representing here. One is APJ School, Park Street, CMS School, Belghuria Jyotindas Vidya Mandir, Belghuria Jyotindas Vidya Mandir for girls, Kontai Public School, Damdam Anando Ashram Sharada Vidyapith, Khalsa Model Senior Secondary School, Loreto Day School, Mohesh Sri Ramakrishna Ashram Vidyalaya, Morning Bells Academy, Ram Mohan Mission High School, St. Francis Xavier School, St. Mary's Orphanage and Day School, the Future Scholars Academy, Vivekananda Academy, the Heritage School. These schools are, one from each school is already presented here. Apart from these schools, if anyone is interested from any other school, please let us know, and you can come here actually. Anyone else is willing to join?
Anyone else? Any other school? Last call. Any other school?
One question from us to participate.
So then we are having questions over here for the
From other school you can send.
any other school, then we can find. Yeah.
All of you, please settle down first. We'll be starting our quiz session.
School go. Apart from the school, anyone can
Can you hear me now? Okay, I am Jyoti Paru. I have not worked as quiz master ever, but I was a science teacher long time, 25 years. So we will do some science quiz. So we have 5 sets of quiz. Of that, first set is direct questions. As you know, quiz happens to be direct questions. And then in each stage, we have one question for audience. Remember, audience, please don't use Google. You can get all answers to it. But some answers, use your brain, try to. If not to worry. We are here to discuss it. This actually, the quiz is for fun. You see here, we are all different schools. There is no school will become first or anything like that. We just want to have a schedule thing so that you can have fun. And if any one of you know the questions which we are throwing to the group, please don't answer initially. If they cannot answer, yes, we will go through. Okay, is it clear? So we will start here. Basically, the basic thing is to know some of the scientific things, some of the scientific personality, and also to get some interest about it. Okay, shall we start? So we have here 16 schools represented by 16 persons. It's divided into 5 groups here: hydrogen, helium, lithium, beryllium, boron. We thought to accommodate 6 groups with 30 schools came and 30 students, but it's okay. We also have constraint of space. So questions are very, very simple. Most of you know the answer, but we will see. I am sorry, the view is not coming yet. Shall we try that?
Pen drive? Very well, because I like everyone to see the question. Meanwhile, I can talk about something about myself. I was teaching many years in different schools. I was basically in North India. I was in Heritage School, Gurgaon, for 6 years. And in 2014, I have taken self-retirement from direct teaching and doing the workshops for science, for teachers and students. So last 2 years, when there was no workshop because schools were closed, no teachers were in the school, I started a channel known as Vigyanology. Start with B. Vigyan means science. So Vigyanology channel, which I start uploading one video each week. So more or less 68 videos are there. Maybe tomorrow one more video will be up, which is mostly the teaching video as well as activity video. Most of it you can see, and I have tried to use some simple materials. So you can acquire the materials and you can do it. So that is what is there. And we will start very soon. But before that, let me tell you clearly that this is for fun quiz, science quiz. Please don't use Google. Google has all answers, and we have very simple questions which you can get answers easily. Is it ready now? We are always told to be best and first when we are in school. But no one can be best and first at anything. Because if you come first in the class, you are only first among the few students in your class and at that time in your life. So when we are planning this quiz, I was very careful not to make it one where there is one best school, one best boy, one best girl, or one great person. What we wanted to do was to give you joy, to make you think, encourage you to go home and try to do things with your own, and to innovate and create new designs, new innovations, and find solutions to challenges. Also, hopefully, we gave you the chance to make new friends and learn new things. You belong to a generation where there is no problem in getting information. Yes. We hope that this quiz give you the inspiration to read a few great books. This is why we choose scientists who are not only one who win Nobel Prize, but also those who inspires loads of others to be sharp thinkers and active learners. When you go back home today, you download a book or look up some of the brilliant scientists and thinkers around the world. Our quiz will be great success. I run a YouTube channel called Vigyanology. I invite you to visit my channel and try out the many experiments. Most of the things you can find around the house or in the market near you. Remain in touch and thank you for your participation. So we are starting here. First question. Okay. So you will have a little problem. Huh? Okay. So first question to hydrogen. Which is the longest neck in the world? Yeah. Mike, take the mic. Okay. Pass. Helium. Quick, you got only 2 seconds. They have 5 seconds. Hmm? It's not working, Mike.
It's Burmese python.
Burmese python. What do you mean by Burmese python? Okay. Okay.
Anaconda only.
Okay.
So the reticulated python.
Right, there you are. Very good. So 10, 5, 4, 3. You will get 3. There's a pen. So we have direct question 10. Then on, as you pass on, so Burmese python, correct, but that is not the reticulated python. What's your name? Tell your name, please.
So Shruto.
Right. So you are very young, right? I thought it's too easy question, but happens to not to worry. Now direct question to helium. Quick, you will get 5 seconds. Don't switch off. That is very specific. Hummingbird happens in many things.
Bee hummingbird.
Okay. Good. Size. Can you tell its size? Anyone? Its size. Bee hummingbird is the smallest bird in the world. Found where? Anyone? No. It's found only in one place. Cuba. And the size. By the way, let me give you a mark. Size is 2.4 inch, means about 6.6 centimeters. It's not that small. Okay, little. Okay, what's your name, please? Good. Okay. Now direct question to lithium. Lithium, what is the nearest star?
Proxima Centauri. Proxima Centauri.
Okay.
Proxima
Any
Centauri.
size? Any distance?
4.25 light year.
Okay, good. Clap. Proxima Centauri happens to be in a group of 3 stars known as Alpha Centauri, which total distance from our place is 4.37 light year around. This is 4.25. Absolutely correct. What's your name? Okay, this is good. Right. Okay, now to beryllium, which is the biggest telescope in the world. Time up. Quick. Oh,
James Webb Space Telescope.
again.
James Webb Space Telescope.
Very good. Well done.
Mission High School.
James Webb Space Telescope. Do you know where it is? Where it is established? Yeah.
It's just launched last year.
Yeah. So you are well aware of it. Good. This space telescope is not on Earth. It's on space. It's rotating around us and taking photos. Good. Now for boron, last question of the round. This is very, very easy. Most abundant element in the universe.
So nitrogen.
Okay, pass,
So aluminium.
pass.
Hydrogen.
Hydrogen. I was just thinking last case discussion happened and he explained so nicely. So everyone would have known. Anyhow, okay. William got 4. Hydrogen is the most abundant element. Hydrogen started. Oh, sorry. Thanks. Hydrogen is a, when you said helium, I thought you were saying answer. So hydrogen is the most abundant element and that started all elements. Good. So now we got one question for audience. What is the heaviest stable element found naturally? Yeah. Okay. Yes.
Osmium.
What?
Osmium.
Okay. Let's see. Yes. Right. Uranium. Which one is stable? No, not you. C had to answer. Uranium. Correct. Answer is uranium. Uranium 238, not 235.
Can somebody now, team member?
Okay, one more question for the audience. What is the deepest point in the Earth's ocean? Yes. Okay, what is the depth? Good that you answered. Answer is correct.
838.
Not exactly. Yes. You see, there are a lot of controversy because Russians saying some depth or something, but actual that depth, which is more or less approved by all, is not 11,000. Yeah. Anyone else? Depth? Yeah. 8,000. Okay, very good. 10,009 to 9 is written here, but it's a good. Well done. Yeah. Okay, so this is the first round. Easy round. Now we are going in a different scale. So this round, let me share with you that this will be all together. We will give you something you have to unscramble. That is, some letters will be there,
and a hint will be given to you as a card. You have to understand. We will show you what we are giving them, but you may not do the thing. Is a hint card given with the star. Open up. You can start. So the moment you have done, whoever will say first will get maximum point and then slowly point will reduce. We have 2 unscramble left. And give you. Good. Good. So, can you read your this thing first? Then say.
This charismatic American physicist won the Nobel Prize for his work in quantum electrodynamics. He is also very well known for his style of explaining difficult concepts in a simple manner. Richard Feynman.
Okay, right. So, others are still doing. So, charismatic American physicist won Nobel Prize for his work in quantum electrodynamics. He is also very well known for his style of explaining difficult concepts in a simple manner. Answer: Richard Feynman. In fact, he has wrote a book. Surely you are joking, Mr. Feynman. It's amazing. Everyone should read. At least I have got a lot of inspiration from that. Yeah, second, can you read the clue?
This Indian aerospace scientist played an important role in India's space program and missile development and came to be known as the Missile Man of India. He has also been a source of inspiration to many through his writings and speeches. So the answer is Abdul Kalam.
Oh, great. Also, he become president. No one else yet? No. Oh my God. I thought so easy. No? Try. Okay. And reading the clues again, if anyone can try. The American woman was a marine biologist before becoming full-time writer. She famously wrote a biomagnification and raised awareness to let the ban on DDT as a common pesticide. Anyone? Any idea? Yeah. Right. So tell them. So hydrogen, can you do this now? Tell again name. So she also written a book, Silent Spring, which is so famous that I have not written there. Detailed Carson. Okay. What Indian woman? This Indian woman is a scholar and activist and is well known as Gandhi of the brain. She did her PhD in quantum physics before doing interdisciplinary research in science, technology, and environment policy. Also was a great activist in especially Narmada Bachao. Yeah. Anyone? Yeah. Okay. Yes. Right. So do it very well. Good. Good. So Vandana Shiva, she was actually a scientist, but gone and done lot of things against Narmada Bachao. Thankfully, Narmada, and he could not stop the time. Now let's come to here. This was not so difficult anyhow. The Indian American astrophysicist won the Nobel Prize in Physics for his work on evolution of stars. His name is associated with masses of white dwarf stars and when they become black holes. But you don't have letters, but still you can tell. No, not exactly. No, Indian scientist. Indian American physicist. Yeah.
Chandrasekhar.
Right. Now do it. Okay. So great. Now two more clue for audience. This phenomenal Indian physicist was the first Asian to win a Nobel Prize in Science for his work on light scattering. Anyone? Yeah. Right. Right. C.V. Raman. Done. So we call it Venkat, C. Venkataraman. So that has not been given to him. Raman effect is in his name. Although by the way, this last year I got a Raman award also. Yeah. Now this may be tough, but let's see. First Indian woman botanist. She is well known for her efforts in conservation of plants as witnessed by Silent Valley National Park in Kerala. Her memory is preserved in white magnolias named after her. Yes? Right, great. So develop variety of sweet sugar cane to be grown in. Well done. Okay. Now we are starting the next round. Next round will be practically shown to you. Sir, sir, sir. Can video be on here so that practical can be shown to everyone? Sure. We will have few practicals done here, which they will choose. Okay. So we will start again with hydrogen, right? So they will tell what is the reaction, how this happens. Okay. And please, you don't tell answer, but later on we can discuss. Sir, camera? Can it be here? Yeah. Okay, camera already it will capture. It will capture.
No. I want that to be viewed to everyone.
It is automatically it will capture. You start it will not automatically.
No, but can you view it here? The table focus should be here.
Yeah. They are doing it.
Can you fix it?
Yeah. They are doing it.
Yeah.
I hope it's viewed to you also. Okay, we had 3 classes here. Okay, question to you. Observe carefully. Okay. See? Yeah. You answer why you stop. One more time. William.
I think some chemical reaction happened there.
Oh, great.
Sir, I think it's potassium permanganate is occurring in the second class, and then I'm not sure about it.
Is it phenolphthalein, sorry?
A little more detail.
Okay, so
Just a second. Yeah, you want to tell?
yeah, so
So we
initially,
have A, B, C. Tell.
so first you're pouring from A to B, right?
Yeah.
So I think B has phenolphthalein solution and you're pouring an alkaline solution into it. So it's turning pink. But then you're pouring that into an acidic solution and that's turning colorless because phenolphthalein solution is a pH indicator.
So it's a phenolphthalein solution which makes any alkaline solution pink. So first one was phenolphthalein already given here. So here was sodium hydroxide, which we pour it here become pink. And then here was hydrochloric acid. When we pour it here, become colorless. It's a very simple thing, which always when I do in the with a birthday, some birthday activity I have gone, they were saying that. So magic is nothing but science. Yeah, next. It's a very simple one for helium. You can see this is just a doll. This does not fall. Okay. Okay. You can have a better version here. It's falling out of it. Okay. So why it does not fall? Helium.
Its center of mass is much low. So when it tilts, its center of mass doesn't get out of the touch point, touch surface.
So
And so as the center of mass doesn't get out of the surface, it's touching, it doesn't fall. It's a,
comes back.
yeah, yeah.
Good.
So basically what's happening is when it's tilting, right, the center of mass rises. So basically you want like the lowest potential energy is like the most stable state, right? So when it's like stable, its center of mass will be right at the lowest point. But then when it tilts, its center of mass is rising because of its orientation.
Right.
So it goes back to the lowest potential energy state. So it's like a pendulum sort of, but then not exact.
This is the best answer. Okay. Otherwise, you have done. Right. No, I mean, when this is tilted, then the center of mass has changed, and so it makes it back to there. Yeah. And so yes, just like pendulum.
Right? So. Lithium. We have to arrange some things so we can hold it. Don't worry. Time. This is what. Okay, question is to lithium, right? It's a very simple question. Question is, yeah, there's no magic. Ready? Observe. Lithium. It's time up. Anyway, the question is, which, what is the principle there? Yeah.
Air pressure.
Okay.
Newton's third law.
Right. So it's Newton's third law. Do it. And they do it. No, don't put it on there. So it's, yeah, want to say something? Phenolphthalein helium or? Oh, right. Thanks. They can't see the mark. Yeah. Who got more beryllium? কত পাস দুবার হ্যাঁ free. Oh, no. This question. Yeah, this question I have not aware. Oh, phenolphthalein was okay. Just correct me. I don't remember. Correct.
The phenolphthalein one was answered by the beryllium group,
Right.
the marks were not awarded.
Okay. It was direct question to first. So 5 4 3. This will get 3. Right? Got it? So 5 is now. 5 is this question. Right. 3 should be before. Right? Correct? Sorry, I'm not. Is it okay? Can you see the marks here? Check. Any discrepancy? Please. Move for it. Anyhow, there is a little failure, but it's okay.
usually goes very fast. It's known as balloon rocket. Anyhow, let's come to next. So now beryllium star, right? So it's a very simple thing I'm doing here. 2 ice cubes. This join. Right. We have to tell phenomenon as well as reason. Two ice cubes pressed, released, join. Quick, your time. Fast, fast.
So there is a thin layer of water on the surface of the ice, and when it is pressed, the water becomes water touches, but when it is released, the temperature again lowers and it freezes back to ice.
Yeah. First, you have to tell the term for it. And then explain. No? No. It's okay. But, explain what is going to do.
দিয়ে চাপ দেওয়া হয়েছে যার ফলে মাঝখানে উষ্ণতা বেড়ে গেছে এবং উষ্ণতা কমে গেছে
আবার
নদীর দিয়ে চাপ দেওয়ার ফলে মাঝখানে উষ্ণতা কমে গিয়ে জমাট বেঁধে গেছে
কমে গেছে
So is this phenomena condensation?
Not exactly.
Or is it force? I think it's recondensation.
Okay. Anyone? Term? Yes.
Come.
Got from the principal in the increase of pressure when yes. Yes. Term. Yes. Raising hand. Tell term.
The regulation.
Right. There you are. There. Regulation. Regulation. Yeah. Reason you have said more or less correctly. But okay, now last question to put on. Okay, one of you can come here. Above the glass. So we have some water here. Sorry, difficult to show. I don't know how to show. Can you see water here? No. Which height? Which height it is? It's here?
right
Oh, acha, you are adjusting it. Can you adjust here? No, right, right. This. Okay, you can see water there.
think someone nearby person. Got something here? You're giving here. This something? I hope. Okay. So what is the phenomenon? Can you explain? Quick.
Sir, I think sodium is given.
Explain the phenomenon. Oh.
I think sodium is given in that solution so that it makes that.
Then why first? Why fire on water? Right. Okay, great. Right, sodium in water. Sorry, I hope it does not burn anything. So sodium in water burst, and can you read the equation?
হ্যাঁ, তো এখানে সোডিয়ামের সাথে জলের বিক্রিয়ায় NaOH এবং H2 উৎপন্ন হয়েছে।
And why fire?
NaOH এর জন্য ফায়ারিংটা হয়েছে, মানে তাপ উৎপন্ন।
Right. Let's see. Anyone can answer this. This is without.
The reaction is highly exothermic and the hydrogen gas produces lights into fire.
And
The hydrogen gas produce lights into flame.
okay, good. So basically, sodium reacts with water and it's highly exothermic reaction. This is spontaneous ignition. Is one of the examples of spontaneous ignition where hydrogen is evolved and hydrogen also burns. Sometimes when we do this, when we take very small amount, it rotates and does not burn. Then we simply take little fire and burn it. Fire is happening on water because of hydrogen, which is highly common. Okay, good. So we have one or two more items for audience. So this I cannot do it here because this is a little tricky. He does better. That face. No, just that one. But okay. So, have you seen it? So we have. Let me explain a little bit. There is a pencil battery. There is a screw, and there is a neodymium magnet below, and a wire is connected. It's rotating. You have to explain the phenomenon. Yes. Yes. Okay, very good. Can you tell the name of it? Yes. Who was it? Who said? Who said homopolar water? Yeah. So what have you told? Please stand up. Okay. Done. Thanks. Thanks for it. So now we have some auto session we will show you a photo. Beware, photo will not be shown for a long time. So hydrogen will start. Okay, we can start the round this time from here, this side. Okay, photon can start. Round will go there. So in this round, you have to observe the picture and identify the image. Okay. So first question goes to boron this time. Yeah.
It is the eye of a fly.
Great. Mouse fly 15,000 times. Great. Okay. So coming to next round for beryllium, right? Yeah.
Picture of a black hole.
Okay.
I mean, can you please show me? I think it's the Sagittarius A star.
Clap, clap. Great. This is the actual picture. The picture which has been given in the newspaper was not actual. It was vague. The actual picture was vague. Yeah. Now, can you guess how we have taken picture of a black hole? Yeah.
By looking for the accretion rate.
So that's we have given the point. Yeah.
So there were many radio telescopes all around the world, and all together formed the large telescope, that kind of thing.
Okay. So it was very, very amazing to get a photograph of a black hole which takes light also. Anyhow. Okay. Now third question to lithium. Yeah. Okay. The question was not exactly that. Question. Okay, correct. Okay. Now tell. Okay. This is demonstration.
Feature.
What? So, no. Anyhow, that should be. Anyhow, fine, we can do that. If not, we can cancel and we can do. But the thing is that, tell me which region it goes. I mean, why it needs to eat insect? Yeah.
And where the mineral, the area with poor mineral, like the plant cannot.
Which mineral?
Nitrogen.
Right there. Then I. Yeah, you got 8. You got 10, but correct. Yes. Indian. Excitement. Say wrong answer. Let's come to fourth It's a very simple thing, but you have to name the actual thing. Helium. You have to give the technical.
I think in nanometer.
Sigmopanometer. Sigmopanometer.
Spell.
Sigmopanometer.
Right. Sigmopanometer. Okay. That is a blood pressure instrument, very common. Do you know how it works? What is the? Yeah, what is in it? Yeah, why we say the blood pressure is 120 by 80? Yeah.
So basically, when the ventricles of the heart pump blood, right? So ventricles have like a higher pumping force because of the thicker muscular walls. So like a higher pressure goes through your arteries. So over there, you get like a higher pressure, which is called systolic pressure. So that's on top, which is higher, and the other one is diastolic pressure.
Yeah, but why 120 by 80?
Because that's the pressure that it pumps at. Like that's just like a value.
Not exactly correct. Yes. Yes. Anyone in the audience? You know what is atmospheric pressure? What is it? How much? How much? We say 760, right? Because 760 millimeter of mercury column equals that. Same way this 120 millimeter of mercury equals the higher blood pressure. Anyhow. Who answered? I guess. Oh, fine. You never had that. Sorry, I'm not good at this. Let you be his best. Yeah. Okay, now next question. This is to hydrogen. This is the animal structure which can be seen from space. Okay, so yeah,
I think it is the Ramsetu.
right. I will show later.
Great Barrier Reef.
Right there you are. Hold on. Hold on. Now I am showing you the picture. Great Barrier Reef, which can be seen from moon, and it's a little part of Australia. This coral reef has been produced only by corals. Okay. Now to audience. Oh. Sorry, picture now we don't have it. Yeah. So last round is video round. This video is quite long video, in between don't talk. Okay. So we will again start with hydrogen. Sanjay. Yeah, hydrogen, can you tell what is?
So, release it can be observed from Alaska and Iceland.
Oh, great, Talia. Tell us. Here your question is, what is the phenomenon? Not what is, you just have to say what is the phenomenon.
এটা হচ্ছে একটা অ্যামিবা ঘনপথ গঠন করে একটা অন্য একটা এককোষীয়
Yeah, it uses pseudopodia. The pseudopodia term for
Phagocytosis.
Right, there you go. Very good. So the phenomenon known as phagocytosis, PHAGOS, phagos means to eat. Mic is working, can you hear? Okay, and cytosis because cell is eating. True, it makes it open. But pseudopodia is not that. Good. Okay, next. For lithium, direct question. Phenomenon. You have to tell the phenomenon.
Ankuladgam.
Okay, see a little more.
Germination. মৃদভেদী অঙ্কুরোদ্গম। So germination.
Phototropism.
Right. Phototropic movement. I'm showing you the whole thing. Wherever light is, that side plant moves, which is phototropic movement. Can you tell why this happens?
So basically, like for the light, there's like a plant enzyme, right? So hormone, right? Oxygen, right? Oxygen. So basically, what happens on the side that light falls, like the oxygen molecules would like lengthen the cell, and on the so like oxygen saturation increases in the darker side. So like it increases on that side and like bend towards the light.
Okay, correct. Okay, now direct question to Beryllium. So you did not say what is this. Everyone knows what is this. You have to say the chemical responsible for it.
So like we don't know the chemical, but the phenomenon is bioluminescence.
Okay, good. Clap. Well, can anyone say what is the chemical responsible? Yeah, phosphorus. No? Yes. Yes. Luciferi, Luciferase and luciferin. Two chemicals are there. So, okay, Abhi, I've given you the mark. Now, Pora, direct question. You have to say the phenomenon. Oh? Okay. Phenomenon. Anyone? The phenomenon of plant plastics moving inside the cell. Yes? Again? Yeah, but there is a name of that phenomenon. Okay, well tried. Yeah. No. It's cyclosis, known as cyclosis. Strangely, plant cell also have this movement to exchange materials. Okay, now question for audience. What is this and why this happens? Yes.
Sir, these are sunspots. This occur due to the deviation of plasma.
Okay. Again, what is it?
These are sunspots.
Right, clap. Now last one again for audience. Term, you have to say the term.
Calculator पर
He wants to answer.
Yeah, phenomenon.
Here.
Yes. Right. Now, strangely, this camouflage is being done by many animals, but octopus does marvelous. We came to know very recently. Yeah. Okay, done. Thanks a lot. It was good. Pleasant to be here. Yeah, sir. Even you declare. Can you? Yeah. That's good. So first is beryllium with 50 points. Second is helium with 34 points. Third is lithium with 46 points. Fourth is just little bit. 25. So it was fun to have it. So I suggest you please read those books like Silent Spring by Richard Churchill. He has changed the whole world. Saying that it's spring will come where no bird will return. Yeah.
My name is Pranjal Sundupta and I am from Rammohan Mission High School.
I'm Shanshan from St. Francis Xavier School. I'm Shruta Kollande from the Heritage School.
say something? I'm sorry, it was not organized properly. But it was not correctly properly.
I am Vipul Roy. I am from Mondos Academy High School.
I'm Chandan Chakravarti from Maya Sri Ramakrishna Ashram Vidyalaya.
HS.
I am Devjyoti Das from Belgoda Jatindas Vidya Mandir.
I am Deepan Burman from Ramnagar NBPC High School.
Tanushka Shaha, Dandam Anandasra Sharada Vidyapit. Bornali Roy of Khasapadi Senior Secondary School. I'm Sneha Ghosh from Ganeto High School, Dharampura.
So, hello. Yeah. Thanks a lot. Other schools, although everyone, but you have worked on it and you have participated very good. Please come up. Let's come.
My name is Sohit Patra and I am from Vivekananda Academy.
My name is Devanki Basha. I am from EPG School, Taxi.
My name is Shamata. I am from School Chennai Japanese Day School.
My name is Purban Janya from Kontakati School.
Yeah, please. Other groups.
My name is Aish Kundu. I am from Central Modern School.
My name is Rahit Mundal and I am from the Future Scholars Academy.
I'm Pushri Agarwal and I'm here to discuss with the photos.
Who's the present? Some of you, and then some others can stand. Thank you so much. It was really wonderful. Mr. Paru? Yeah, we just wanted to felicitate you in the beginning itself. Yeah, we wanted to felicitate you in the beginning itself, but somehow with the arrangement, we couldn't do it at the beginning. You are, thank you so much for, coming here And we are really grateful for this. And this was a wonderful session. All have enjoyed. So now, so for today, we are closing here, and tomorrow again we'll see you at around 10 o'clock in the morning. So you can come to the Isaac building this morning where you came. Come to Isaac building, and we'll give the coupon so for tomorrow. So you need to collect the coupon for tomorrow from there. Otherwise, no other formalities. And again, the session is starting as per the schedule. Its schedule is with you. So have a nice evening. Enjoy, take rest, and come back with a lot of energy tomorrow morning. Okay, bye.